Example problems of what we're going to do with this knowledge of transformations. Very simply here, we're going to look at the function y equals x squared and transform it into y equals x squared plus 5. What does that do to the graph? Well, that plus 5 is adding to the function, so I believe it's a vertical slide, and we learned that positive numbers make the slide upward. So vertical slide, 5 units up. Okay, the next one, y equals x minus 3 squared. So it looks like we're subtracting from the input, and the input means it's a horizontal slide. So this is a horizontal slide. And we found that when I subtract 3, it actually moves to the right. Okay, graph it to verify. X squared minus 100, once again, we're subtracting from the output. So that's a vertical movement, so vertical slide. And since we're subtracting, we're moving it down 100 units. And we can do a combination. And here, sorry, that is affecting the input. So that is a horizontal slide, and that's going to be 50 units left since we're adding. And then the minus 299, we're adding or subtracting from the output. So it is a vertical slide down 299 units. Okay, now we'll look at the square root of x, same kind of thing. X minus 5 looks like we're subtracting from the input, so that's a horizontal movement. So horizontal slide, 5 units right. Now this is a little tricky. Now do things in order. I don't see any parentheses, so I'm just going to charge on. When I add 3 to the input, okay, now that's a slide 3 units left. All right, so the graph is actually going to look a little like this. You know, we started off, that's y equals x. So moving to the left is going to move it here. All right, now we look at this opposite of x. Now that's a flip or a reflect. So then you reflect, and it's horizontally, so we're going to go over the y-axis. And now you'll see that this, my vertex, if you will, flips across the y-axis, and then it goes that way. So probably want to graph that and convince yourself, but just work in order, work left to right. Okay. We could be asked to do something like this. I don't know why that's there. We can be given a function and then say how to transform f of x to where it equals g of x. All right. So first thing, now this one I'm going to work inside the parentheses first. So if I'm getting from x minus 1 to x plus 3, it looks like I got to add 4 to f of x. All right. And then I've got to flip. So I got to flip it since it's negative of the function itself. I've got to flip the function in order to get a flip over the x-axis. All right. Then you should try that. Graph that, or graph both of these, and then graph that. And you should see that g of x and that function, the opposite of f of x plus 4, should be the same function.